Good day, students. Welcome at this second tutorial. Today I want to talk about, in this video, about z-scores. So about the standard normal distribution and how to produce those z-scores, so standardized scores concerning the normal distribution. Okay, if we want to produce those z-scores, what we're going to do, first of all, for instance, if we take this variable gender, 1s and 2s, can we standardize this into the standard normal distribution? Your answer should be no, because this is a categorical variable. We cannot standardize this. What can we standardize? For instance, age. So we want to standardize age and make z-scores of it, and to try to get a view if age in this data sample is normally distributed. Okay, what is the way to get z-scores? First, you go to Analyze, then you go to Descriptives, the Descriptive Statistics, then you go to Descriptives, you click on age, so age was probably in your box here, then you plug it in, and you click this button, in that sense, like save standardized values as variable. Now we can look at some options. Maybe you want to know the mean, we don't want to know the maximum, the standard deviation, etc. This is not that important now. We click on OK. We get a new box and it shows us, yes, the mean is a little over 48, the standard deviation is 17.72, a little over or almost 1900 or 1900 cases. Okay, this is not interesting for us. We want to know where are the z variables, the z scores. And if you look in your data file, you see zage, and zage is just the z-scores of age. So how is this number here produced? This 109361. It is standardized, and you should now know that the standardized formula was you have an observations minus your mean divided by the standard deviation. So if we want to reproduce this number here, how is it done? Not very difficult. We look at the first age, so it's 86 minus the mean, and we all know what the mean now is, minus 48.62 divided by 17.72. This gives us our standardized value of 109361. This is done for each variable in the data file, so almost 1900 times this is done. So these are all those standardized values. So this one is produced just by the actual age minus the mean, so that's 48.2 48, a little over 48, divided by 17.72. Yes, so these are how these numbers are produced. So another thing we want to do, we want to also know the percentiles. So how do we create the percentiles? We go to transform, then rank cases, and if we want to rank cases, we use age. And we don't want to rank them, actually. We want to know the proportion estimates. And for proportion estimates, there have been a lot of guys within statistics who concerned themselves with proportion estimates. We just take the Bloom approximation. So more in the sense there are more guys, even a Dutch guy, Van der Waarde, who are busy with this. We just take the default option, Bloom. We click on continue. We click on OK. What do we see? We get an output. In this output screen, we don't see a lot, so just click it away. What do we see actually is happening is there is an other variable called page, the percentile of each individual case. So now we know the z-score, so the standardized score, and we know what the percentile is of this specific case. And actually this percentile stuff is going to be not a percentile only, but it's also going to represent chance. Another thing we can do, for instance, is rank these variables. And ranking them in the sense from the lowest to the highest. And there are several ways to do this. You can do this with data and sort cases. I won't do it in this fashion. This is, let's say, the standard official way. But you can also click on your right mouse button and then sort ascending. The same. We get again our output screen, and what do we see? This is the smallest value, and we see the percentile and also the chance of this. Okay, so it goes from 1.897, and we go down and down and down and down and down, and what do we see? Eventually it goes to positive numbers, and what is the highest positive number? That is, let's say, a little over 2.5. So it's from minus 1.9 to plus 2.5. So you can actually, if you have because you already know the normal distribution, this is not actually the normal distribution. This is an empirical distribution, but it shows features of the normal distribution. Why? The normal distribution is from minus 3 till 3, and this one is from minus 1.9 to 2.5. What do we see besides that? These were the standardized scores. So this was the standardization process. Actually, we see those chances. They come from almost 0 to, if we look in the end, to almost 1. So this page is also functioning as the surface under the normal distribution, or the surface under this empirical distribution, which has tendencies to the normal distribution. So you can read this as chances. Okay, this should be clear. More in the sense like this is just a normal an empirical distribution that looks like a normal distribution with chances in the form of percentiles. So if you want to have a more thorough understanding of this, just make a histogram of those things and you will see what's happening. Okay, I just wanted to show you how to create those C-scores, so those standardized scores, and how to get the chance or percentile of those scores, and this is the way to do it. Okay, thank you for your attention.